Alright, let's go through the tests. First it says find the average velocity between 0.25 and 1.5. And so, excuse me, average velocity is just the slope, and so I have to take the 14.13, the height of the distance at 1.5 minus the distance at 0.25 divided by 1.5 minus 0.25, which is, doing a little calculator work here, 14.13 minus 6.55 is 7.58 over 1.25 is 6.064, and this is in meters and seconds, and this is meters and seconds, so meters and seconds, so it's meters per second. Determine S prime there using the central difference. The central difference says to use the one above and below, so I would do 19.58 minus 10.36 over 1.75 minus 1.25, or I could have done 2 times 0.25, and that gives me, let's see, 19.58 minus 10.36, 9.22 divided by 0.5. That's the difference there. And I get 18.44. And again, this is distance and time, so it's meters per second. And then finally the linear approximation. Now this is for S, so the answer is going to be in meters. So linear approximation, I'm going to have to center it not at here, but center at something I have, which is 1.50 is the closest, and so I need to know the slope at 1.50, which is S prime, which we got as 18.44 parenthesis x minus 1.5, the x value plus the y value, which is 14.13. And so working this out, I get, putting in now 1.47. 1.47 minus that is negative 0.03 times 18.44 is .55, negative 0.55, so I get plus the 14.13, and I get 13.58 rounded. And again, this is S, and so it's the distance, it's in meters. Okay, we got the bungee jumper, so I'm going to go and type the equation in. I'll do it right here in Y2, and I'm going to type in 100 cosine 0.75 x for the t, close parenthesis, e to the negative 0.2 x. And if you're doing it on another calculator that doesn't have the doesn't put it up here and it does a caret, then you have to put this all in parentheses. Okay, plus 100. And so turning off these other equations that I got in here for another class. So the only one I have on is that one, and so I'm going to go second table, and I'm on ask, and I want to put in 12. And it says 91.73. So h of 12 would be 100 cosine 0.75 times 12 to e to the negative 0.2 times 12 plus 100, which comes out to be 91.734, and this is, the height is in feet. And to answer the second question and tell what the value means, after 12 seconds, the bungee jumper is at a height of 91.734 feet. Okay. H prime of 12, using the limit definition. So I need to see that you did the limit definition. So H prime of 12 is the limit as H approaches 0 of this cosine of 0.75, and for the t it's a plus h, and a is 12, so it's 12 plus h, which I'm going to put in the calculator as x, but I'll put it as an h here, and I need to close the parenthesis for this and for this. E to the negative 0.2 times 12 plus h plus 100, all of this minus 100 cosine of 0.75 times 12a, e to the negative 0.2 times 12 plus 100, and this is all in parentheses, all of that over h. And I think I have almost that in here. Okay, so go here, and it's supposed to be at 12. So I'm going to go to put 12 in there. 1, 2, and I need to put a 12 there. And then I have to go over here and put in 12. And here. And there's the 100, close parenthesis, over x. So now I can go to the second table. Delete that. Now I want to put, is that one on now? Yes, I don't need to see that one. So I'll go back on the equal sign, press enter, go second table, and I need to put close to 0. 0.01, 0.001, 0.0001, negative 0.01, negative 0.0001, negative 0.0001. Okay, so it looks like it's going to be negative 1.151. It's approximately equal to negative 1.151. So this is the derivative. The derivative of a distance graph is the velocity. And or if you will, this is all distance formula over what this calculates the change in distance over the change in time. So and the distance is in feet and the time is in seconds. See, what sentence explains this meaning. At 12 seconds, the jumper is falling, because it's negative, at negative 1.151 feet per second. Determine whether h double prime of 12 is positive or negative. Well, the double prime talks about the slope of the slope, yes, but it also talks about the curvature of the original graph. So I'm going to go back and turn this one off and turn on my original graph, and then I'm going to go zoom 6, and I'm not going to see much. So I need to see 12 seconds, and I need to see as high. So x, the time, can be 0 to, let's say, 15, so I can get out to 12. And the height, 0 to, and it looks like I got 100 plus 100 is going to be 200 maximum height. So I'll put 250, putting a mark every 25, let's say. And graph. So I want to look at 12 seconds. So I'm going to push trace and get out here to 12 seconds. I'm in the 12-second area right around here, and that looks like it's concaved up. So at 12 seconds, h of t is concaved up. So h double prime of 12 is greater than 0. Positive. An equation of the tangent line. L of x at 12 would be f prime of 12 times x minus 12 plus f of 12. And we've worked all those out already, so that's going to be, so the linearization at a equal 12 would be f prime of 12, we got negative 1.151 x minus 12 plus f of 12, we got to be up here 91.734. And this line would approximate heights near 12 seconds. Okay, page 2. I mislabeled this. This is the top graph is the derivative. So this is f prime of x. And in the middle graph here, at where a is, we're supposed to draw f. So if this is the derivative, this is telling me the slope of this one. And this is at a height of 1, so the graph here has to have a positive slope of 1. So if I just start here and start going up, and then it drops to a no slope here, which means I have to max out at -2. So I just keep going up until I'm getting close to -2, and I'll just make it top out. Then the slope gets to almost to -2 in this area. So it goes down almost to -2. -2 would be like this, so that's almost -2. And then it goes back to 0 slope here. Let's see, this is at between 5 and 6. Goes to 0 slope, so it's going to have to bottom out between 5 and 6. Goes to a positive slope, not very steep, maybe a half. So it's going to be a half. Slope of a half is up 1 for 2, so it's something like this. And then it goes to 0, so I have to top out at almost 9. And then go to a negative slope again. The height of this graph is telling me the slope of f of x. Now, here we're supposed to do in part C, says to make f double prime of x. I'll do that before I do b. So that's the derivative of this. Well, the slope of this is 0. Then it goes to -1 about here at -2, and then it goes back to 0 by the time I get to, a little past 2. Goes to 0, so it goes down, and it comes back up. Got down to -1. I made it go down too low probably, so probably -1, back up. Then the slope gets up to not quite 1, and then the slope gets back to 0 at 7. Slope here is 0, and then it looks like it's not quite -1 again. And kind of holding steady here, so it should come down and then kind of go flat. So something like that is that derivative. What did the zeros on f prime tell us? Well, this 0 tells us we're at a max. This 0 tells us we're at min. This 0 is telling we're at a max. It could be something else, but in this case particular, it's a max or min of f of x. I specifically asked, what does the first derivative tell us about the original function? It could also be a kind of a flat inflection, a place where it goes flat and then goes down. That would have a slope of 0, and so the derivative would be 0. Or it could be coming up. That's the other thing it could be. How about what does the zeros of the second derivative tell us? Well, this is 0 here, and this is about f, not about the derivative. So we have to talk about what this means here. Well, f is a straight line when this is 0, if it holds 0 for a while. If it's just 0 for a point, that means it's changing curvature from concave down to concaved up, or concaved up to concave down. It's an inflection point. So it's either an inflection point on f, of x is straight. When it's straight, this is 0. This would be acceleration. Distance is constant, so it's not accelerating. Or it changed from going more, slowing down to speeding up, or from speeding up to slowing down. That's what's going on. When it's 0, it's changing that direction. Okay? Next problem. As we come towards 2 from the positive, the graph goes up towards 4. As we go towards -3 from either side, it's headed towards 5. As we approach -6, and it doesn't say from left or right, so we've got to go both ways, and it's approaching 6. As we approach 2, it doesn't say from the positive or negative, so when we go to 2, it goes to 4 from the left, 7 from the left, 4 from the right. So this does not exist because, explain why, because the left limit does not equal the right. Okay, using the same graph, we're supposed to answer these. Determine whether it's continuous at -6. Well, 3 things have to have, 3 conditions. It has to have a limit, has to have a value, and they have to be equal. At -6, there's no value. So it's not continuous because there's no value. At -3, it has a limit, it's 5. It has a value, 2, but it's not continuous because the limit does not equal the value. At 8, out here at 8, there's a cusp, but it has a limit and it has a value, and they're equal. So even though there's a cusp, it's continuous. At 2, it's got 2 problems. It doesn't have a limit. It has a left limit and a right limit, but it doesn't have a limit, and it doesn't have a value. So you could put down either one of those. Not continuous. No limit, and no value. And finally, is it differentiable at -6? Well, at -6, there's 2 conditions for differentiable. Has to be continuous, and it has to not be a cusp. Well, it can't have a cusp if there is no value, but it's not continuous. We've determined that already. So, not differentiable because it's not continuous. Okay. Last page. Limit definition. So we're trying to find f prime of 2, which is going to be the limit as h approaches 0 of this a plus h, so it's going to be 2, because a is being 2, plus h squared tangent of 2 plus h minus 2 squared tangent 2 divided by h. So I'll pull out the calculator. Yeah, I know my better. So turn off this equation. I'll go way down here and put it here, and so I have to have in my numerator, let's see, I can do this on this calculator, alpha y, make it do pretty print, it's called, parenthesis 2 plus x, close parenthesis, squared, tangent 2 plus x, close parenthesis, minus, and I could put parentheses on the second part, but there's no addition, so it's not going to distribute, so I don't need it. 2 squared I know is 4, tangent 2, close parenthesis, and x, and then second table, pick numbers close to 0, which I just did a little bit ago, and I get, looks like about 14.36. Okay. Determine the equation of the tangent line. That's the linear approximation at x equals 6. So it's f prime of 6, which they tell me is 4. That's convenient. X minus 6. And, they tell me that f of 6, which I need next, is 27. Boy, that was an easy one. Use this to predict 5.8, so I'm going to put 5.8 in there, and I'm going to get 4 times 5.8 minus 6 is negative 0.2 plus 27, so that's negative 0.8 plus 27, so it's 26.2. And is this value expected to be an over or under estimate? Well, they said the second derivative is negative. So the curve is concave down, and so the line at 6 has to be above the curve, on the curve at 6, but any place else before or after, the line will be over it, so it's going to be an over estimate. Because f double prime is less than 0, so concaved down, and the line will be higher than the curve. Done.